Welcome. We are looking at factoring right now, kind of making sure that we remember all the different parts. So I very specifically chose each of these because all of them together encompass all the different things that you need to remember about factoring. So let's go ahead and look at this one first. And with factoring, what you're trying to do is you're trying to change an addition problem into some sort of a multiplication problem. So what we want to look at first is if there's something in each of these that can be divided out. Taking out the common factor might sound familiar. So a 2 is a factor of each of these, and in terms of the x's, an x squared is a factor of each of those. So if I take that out, I'm dividing the 6 by 2, which gives me 3, and I am dividing, I'm saying that x squared times what would equal x cubed, and so that would be just x. So again, 2 times 3 is 6, x squared times x is x cubed. And then what we're left with in here, I pull out all of the x squared, so that disappears, but 8 divided by 2 is 4. So in other words, if I multiply this guy by this, I would get this as my answer. Second one, very, very similar, except for when you're looking at the numbers, there's nothing that's common, but there is an x squared at least in both of them, and there's a y at least in both of them. So what would I multiply this by to get back here? I need a 3, and I need an x. The y is already taken care of. So 3x cubed, y gives me that. Here I need a 4. I don't need an x at all because I have already my x squared, but I do need a y. So if I multiply this times this, I get 4 times x squared times y squared. This guy here is called the difference of two squares. And if I factor this, the superbly easy fashion is I square root this, and I square root this. Now, here's the deal. X times x is x squared. Awesome. 4 times 4 is 16, but I need it to be negative, so one needs to be positive and one needs to be negative. Now, the only other one that would need to be multiplied is, remember, the inners and the outers. So this is negative 4x and positive 4x, so those are going to disappear. So I'm going to give my x squared when I multiply those two, plus 4x minus 4x, and then minus 16, which gives me my answer. Now, that's really nice because that's exactly the same thing you do here. 4 is a perfect square, 9 is a perfect square, it's a difference. So if I do the same thing and split up 2x and 2x, and split up 3 and 3. So 2x times 2x is 4x squared, 3 times 3 is 9, but I need one to be a positive and one to be a negative in order to get my answer. And then let's just check to make sure. So I've multiplied these and these, but the innies and the outies are plus 6x minus 6x, which will disappear. So that would be the factor of that guy. So then we get to these guys here, and we have x and x. There's really no other option for that one there. And I'm multiplying what would multiply by 16, but that would give me my 8. So 4 and 4 would do that. They both need to be positive. And 4 plus 4, so innies and outies, 4x plus 4x is 8x. 4 times 4 is 16. X times x is x squared. Let's look at two others that are pretty similar to that. Let's look at this one here. Again, there's no other option for my x's, like x times x is going to be my x squared. We've got that. I'm finding out two things that I multiply to get 8, to add to get 6. So that would be what, 4 and 2. So 4 times 2 is 8, and 4 plus 2 is 6. But I need these two to multiply to get a positive 8, and these two to combine, so negative 2 and negative 4 to get my negative 6. We're going to do the same thing here. I need to multiply to get my 12, so like 3 and 4. And I need to subtract, because one of them needs to be positive, to get negative 1. So I need this to be negative and this to be positive, so that will give me negative 4 plus 3. That would give me my negative 1. But when I multiply them, I get negative 12, and I want to multiply those, I get an x squared. So then we get to these guys here, which are a little bit tougher. Now, you can do this kind of guess and check method that I have been talking about. But there are options, like this could be 1 or 9, this could be 3 or 3, this could be 4 or 1, that could be 2 or 2. Not that many options, so I could just kind of guess and check and hope for the best. But I do want to look at what else you can do as an option. So what I also can do is multiply these guys here and that gets on, I'm sorry, those go on the top. Wow, it's been a little while since I've done it the old-fashioned way. So I multiply those to get up top, so it's kind of like throwing them up to the top, and then this guy gets down in the middle, so that's negative 12x. So I'm trying to find two numbers that multiply to get 36, not 9, 36, and adds to get 12. So that would be negative 6 and negative 6. Now, I need to get here. So now what we need to do is we need to rewrite this. So we have 4x squared minus 6x minus 6x plus 9. So that's what that would look like, and I got these is really this guy kind of separated out. Here now I can factor by grouping, so I can figure out what can I take out of both of those. So that would be a 2x, and I'm left with 2x minus 3. And here I am left with, if I take out a negative 3, I'm left with 2x minus 3. So 2x minus 3 I can now take out of both, and I'm left with those guys there, which is 2x minus 3. So let's just check this. 2x and 2x is 4x. Negative 3 times negative 3 is 9. And this is negative 6x and negative 6x, which gives me my middle terms there. So let's look at this one here. This one, I don't have that many options. I have 2 and 1, like that's it. And then here I've got, what, 21 and 1 and 3 and 7. Like, I just really don't have that many options. So what I can do is say, well, it's not going to be 21 and 1 because these guys here, when I multiply these together and multiply those together, they need to combine to get a negative 1. 21 just makes them all too big. So if I look at 3 and 7, if I put the 7 here and the 3 here, that gives me 7 and 6. And I want to have the 7 be negative and the 6 be positive. So I've got my 2x squared, my negative 21, my negative 7, positive 6 gives me my negative 1. Let's look at this one here. This one here is not too bad either because I don't know what the coefficients are, but I know that one of them has to be 3 and one of them has to be 1 because those are my only options. So my only options for the numbers that go in front of here are 6 and 1 and 2 and 3. Again, the outers and the inners need to combine to get my 7. So remember, one of these needs to be negative, and I'm not sure which one it is, so I'm going to hold off on that. But that means I need to subtract to get a 7. So if I put the 2 here, that would be 6 and 3. That's not going to work out. But if I put the 3 here, that would be 9 and 2. So 9 and 2 will subtract to get 7. Now remember, I want a positive 7, so that means I want a positive 9. So again, 3 times 2 is 6, 1 times 3 is negative 3, and 9 minus 2 is my 7. So that would be the factoring job for that guy.